lesson 12.3, we're going to look at probability, and then we're also going to look at odds and how probability and odds are related. Let's look at this first example. Oh, one thing you want to keep in mind, and this will, when we talk about odds, I'll talk about the difference between the two. But probability always compares. So probability is always successes over total. Okay, and we'll talk about how it is different when we get to odds. When 3 coins are tossed, what's the probability that all 3 come up heads? We are going to make a tree diagram for this. I'm going to have first, second, third, meaning first coin, second coin, third coin. When I flip that first one, I could have a head or I could have a tail. Okay, if I get a head on the first one, 2 possibilities on the second one, a head and a tail. Let's do the same here. If I had a tail on the first one, a head and a tail. And then on the third one, if I had a head and a head, now I come here, head or tail. So I'm going to have branches off of each of these with a head or a tail. A head or a tail. So if I said list the sample space, then we're going to try and figure out the probability here. This is sample space, and you need to know what sample space is. It's listing all the possible outcomes. So if I follow the top of that tree diagram there, it would be head, head, head. And then I would have right here, head, head, tail. So head, head, tail. And then I would have head, tail, head. And then I would have head, tail, tail. Now I come down to where I had a tail on my first one, head, head, tail, head, tail. And then we're coming down here in the bottom, tail, tail, head. So tail, tail, head, and tail, tail, tail. So there are 8 possible outcomes. So when we're doing probability, it's going to be out of the total. So it's the successes out of total. Now when I'm talking about successes, we are talking about all 3 coming up heads. So the total is out of 8. And if I look over here, how many of these 8 have all 3 heads? Well, it's just that one right there. So there is 1 of them out of 8. If I said, what's the probability that I get 2 tails? Well, then I'd look for ones where I have 2 T's in there. And then we get into exactly 2 tails or at least 2 tails, and it gets a little trickier. But it's always out of the total. So it's 1/8 as a fraction, which if you divide it would be 0.125 or 12.5%. Okay, probability can be listed as a simplified fraction, decimal between 0 and 1, or a percentage between 0 and 100%. Probability with combinations. Okay, let's look at this example. Roman has a collection of 26 books. So that's my total number of books. I've got 16 fiction, 10 nonfiction. So that's kind of the breakdown of those 26. He's going to pick 8 books to take with him on vacation. And what's the probability that he chooses 4 fiction, 4 nonfiction? So I wrote some things down. I would suggest writing this down for you. Total number of books is 26. He's going to take 8 of them. And he wants 4 fiction, 4 nonfiction. So when we do the probability, and I would suggest writing this down right here in your notes, pause the video if you need to. The probability is the ways, we're going to look at the successes, which is the ways of selecting 4 fiction and 4 nonfiction, and we're going to divide it by the total, which is the ways of selecting 8 books out of 26 total, of any way of choosing 8 books. So what you're going to do on top is you want to look at fiction, nonfiction, and it's going to be combinations. You're going to do the number of combinations. Let's do the how many possible ways could I select for fiction? Well, there are 16 fiction books to pick from. That's this right here. And I'm going to select 4 of them. And then we're going to multiply that by the number of ways of selecting for nonfiction. There are 10 nonfiction books, and I'm selecting 4. So we're going to multiply those 2 together on top. And then on the bottom, we always divide by the total, which is just how many ways could I select 8 books from 26. So that would just be one combination, 26 total. How many ways could I select 8? So there's basically the calculation you need to do on your calculator using your combination button. So if we go through and do that, and I'll actually show that to you, I guess. So let's go through and do that. So let's do the top first. So we've got 16, choose 4, so 16, and then I want to go to my math button, arrow over to probability, combinations, so arrow down to combinations, and 4. So as you can see, that's 1820. So here's what we have. We really have 1820. Now let's do number of combinations, 10, choose 4 on our calculator. So 10, math, probability, combinations, enter, and 4, enter. That's 210. So if we go back, that's times 210. And then we're going to divide 26, choose 8. So if we go back to our calculator, 26, math, probability, combination, select 8. It's a pretty big number. It's over 1 million. So it would be 1,156,2275. And if you go through and multiply on top and then divide by that number, you should get 382,200. So 382, and I'm not going to show the calculator. You can check that on your calculator right now. But that would be, I'm sorry, that's the top, 382,200. And then we're going to divide by, let's erase that. So if you go through and actually, that would be what you get on top, and then you'd have to divide by that 1,562,275. And you should get about 0.245, which is about, if you listed it as a percentage, 24.5%. So there's about a 24.5% probability that that would happen. All right, now we're going to get into odds. And odds, when we look at odds, odds compare successful to unsuccessful. Notice probability was successful to total. So if you had probability, that's success over total. Odds is success over unsuccessful. So the odds of something happening is success over unsuccessful. And a lot of students, when I ask an odds question, give me a probability answer. Okay, we got to make sure we're doing successes over unsuccessful. So before I get into this word problem, let me just give you an example here. If I said the probability of something happening is 3 out of 7, what are the odds that it happens? If you do this, that's success to total. That means there's 3 successes out of 7 total. So if I've said how many then are unsuccessful, well, if there's 3 successful out of 7, you could subtract 7 minus 3 and there would be 4 unsuccessful. So what you want to do is you want to deal with the successes and the unsuccesses. If I said what's the odds of something happening given that probability, there would be 3 out of 4, or you could do it as a fraction. It would be successes over unsuccesses, 3 to 4. A lot of times with odds, we write it this way right here with the colon. I kind of do that to keep it different from probability, but you could write it as a fraction. If I said the odds of something happening are 5 to 7, so if I said the odds were 5 to 7, what's the probability? Well, the odds are successes to unsuccesses. Probability is success to total. If I found a total from that, that would be 12. So that would be 5/12. So you can go back and forth between odds and probability, and you'll be asked to do some of that. I don't have a specific example like that, but let's go back to this. It says, according to the U.S. National Center for Health Statistics, the chance of a male born in 1990 living to be 65 years of age are about 3 and 4. That's probability. For females, 17 and 20. So in other words, that they live to at least 65, that's the probability that they are. So we're trying to find that the odds here that they die, okay? Now, you got to really, it gets a little tricky the way this is worded, okay? 3 in 4, so 3 out of 4 live past 65 or to 65 or greater. So that's 3 successes out of 4 total. That means that 1 out of 4 die before 65. Okay, so if there's 3 successes, there's 1 out of 4 that are going to die. So you got to really, and that's what we're talking about right here. So the probability that they don't live to 65 or that one is 1 out of 4. So what are the odds? That means 1 out of 4 success to total. So unsuccessful then is, if I take the total 4 and subtract 1, would be 3. So what are the odds that they die before that? It would be, we're talking about the odds that they die. So that would be successes to unsuccesses. So here's my successes, here's the unsuccesses. So it would be 1, 2, 3. What are the odds that a female, now we'll look at the females, die. So the probability that they live is 17 out of 20. That's the probability that they live past 65 or 65 or greater, which means the probability that they do not live that is 3 out of 20, that they die before 65. So we're talking about, I know this sounds weird, but the successes are them actually dying. That doesn't sound successful, but that's what we're really talking about. So there's the probability. So the unsuccessfuls would be 17 then, if I take 20 and subtract my 3. So we're talking about that they will die. So successes are 17. Failures or unsuccesses, I call them unsuccessful over there, but failure would be 3. So we're really talking about this being that means, oops, I'm sorry, that means I have that backwards. We're talking about being successful here is that dying, so that means that 3 are going to die and the unsuccessful is 17. I had that backwards. This should have been unsuccessful, so just ignore that. Okay, we are looking at 3 successful, so that's successful right there, and then 17 unsuccessful, so the odds that they die is 3 to 17. It just gets a little tricky the way that's worded. Okay, last thing here, probability distribution. This is an example when 2 dice are rolled. Use the graph to determine which outcomes are least likely. What is their probability? Okay, notice the lowest probability is what we're looking for here, and that's getting a sum of 2 or a sum of 12. The only way that can happen, it's 1 out of 36. The only way you can get a 2 when you roll 2 dice is getting a 1 and a 1. So the least probability is 1 out of 36, and that is sums of 2 or 12. A double 1 or a double 6, and there's a 1 out of 36 chance. B says use the table to find the probability S equals 11. That means that the sum is equal to 11. So if I look out here, the probability of the sum's 11 is right here. That's a 1 out of 18. Now really that came from 2 out of 36, because you could get a 5 on the first die and a 6 on the second one, or you could flip-flop it, get a 6 on the first one and a 5 on the second. So 2 out of 36, which in reduced form is 1 out of 18. What other sum has the same probability? And that would be a sum of 3. That's also 1 out of 18. That's getting a 1 and a 2, or a 2 and a 1. So 1 out of 18, 2 out of 36. What are the odds of rolling a sum of 5? Keyword here is odds. Okay, probability of a sum of 5. If we look at our table, the probability of a sum of 5 is 1 out of 9. That's success to total. So if I want to find failures or unsuccessful, so whether you want to call it F for failure or unsuccessful, if there's 1 successful out of 9, that means there's 8 unsuccessful. So the probability, if I want the odds, I'm going to do success to failure or success to unsuccessful. That would be 1 to 8, or if you wrote it as a fraction, 1 out of 8. Success to failure or success to unsuccessful. And that's lesson 12.3.